Current, charge and power. Now, a reminder from Unit 1, power is the rate at which energy is transferred by an appliance, and it's measured in watts. 1 watt, capital W, is a rate of transfer of energy of 1 joule per second, and 1 kilowatt, little k, big W, is a rate of transfer of 1,000 joules per second, or 1 kilojoule per second. Now you can calculate the power of an appliance using the equation P equals E over T, where P is power in watts, E is energy transferred to the device in joules, and T is the time taken for the energy to be transferred in seconds. So have a go at this. A radio transferred 3,000 joules of energy when it was switched on for 10 minutes. Calculate its power. Stop the video, have a go at that, and then look upside down and check your answer. Now, if you're doing the higher tier paper, you need to be able to calculate charge. Now, if we know the energy transferred and the PD, we can calculate the amount of charge that flows using this equation off your physics equation sheet, E equals V times Q, where E equals the energy transferred in joules, V equals the potential difference in volts, and Q equals the charge in coulombs. So you might get a question like this: how much charge flowed through a bulb when 15 joules of energy was transferred to it with a PD of 1.5 volts? So use that equation, E equals V times Q, pause the video, turn upside down and check your answer. Now, current can be calculated as well. You need to do this if you're doing the foundation tier paper as well as higher. So if you know potential difference and the power rating, then you can calculate the size of the current using this equation from the physics equation sheet, P equals I times V, where P is power in watts, I is current in amps, and V is PD in volts. We've met all of those terms before. There's a useful triangle. We can therefore calculate which size fuse to use if you know the PD and the power rating. So you might get a question like this: a hairdryer has a power rating of 3 kilowatts and a PD of 230 volts. Which size fuse should be used? 3 amps, 5 amps or 13 amps? So pause the video, use that equation and check your answers. If you're doing higher tier, you need to be able to calculate the energy transfer in a circuit. Because energy is transferred to each component in a circuit, you can calculate this. So for example, a 1.5 volt battery provides 1 coulomb of charge with 1.5 times 1, which is 1.5 joules of energy. That's using that equation from the physics equation sheet, E equals V times Q. So this is shared between the components in the circuit, but not necessarily equally, depends on the component. So let's have a look at this diagram on the right. How much energy was transferred to each bulb by 1 coulomb of charge? So you need to calculate it individually for each component. So calculate separately for the 2 bulbs. Use this equation, E equals V times Q, and the PD rating for each component is given separately. So pause the video, carry out that simple calculation and then check your answers.